Okay, difference of squares is when you have only two terms. Okay, so there's a couple things you need to notice. The first thing is only two terms. Difference is referring to subtraction, and squares are referring to square terms. Okay, so you're probably familiar with like 1, 4, 9, 16, 25, 36, all of the perfect squares. But anything that can be written as a square is going to be considered to be a square. So even something like x squared, that's a squared term because it's literally squared. Even something like x to the fourth power, we could consider that to be a squared term because you could write it as x squared quantity squared. Just drop that down. All right, so anything that can be written to the power of 2, we're going to consider that to be a square. All right. Okay, so I noticed that x squared is definitely a square. I noticed that 81 is a perfect square because we have 9 times 9. And we have difference. Okay, those are the three things we're looking for. Look for the two terms, make sure that they are both squares, and make sure that they're being subtracted. All right. And then this is going to break down. So the formula you need to know, and this is going to come up in a lot of pre-calc and in calculus. The formula is, whenever you're in this situation, we factor this as a plus b times a minus b. Okay, so essentially to identify your a and b terms, you just start with your original and then take the square root. Okay, we're going to take the square root, and that's going to tell us what the a and b terms are. All right, so difference of squares here is going to factor as a plus b and a minus b. So if I was to take the square root of this first term here, x squared, the square root of x squared is just going to be x, right? Because they're inverse operations, they're going to undo each other. So if I was to take the square root of the second term, which is 81, we know that that's just 9. Okay, that's what makes it a perfect square. 9 times 9 is 81. What makes x squared a perfect square is that x times x is x squared. All right, so when any number or variable that you can multiply by itself is going to be squared. Okay, so here I'm going to open up my parentheses, and we're just going to take these terms. So it's going to be x plus 9 and then x minus 9. And just like in the GCF method of factoring, we can also distribute and make sure we have the original problem back. So here we have a little process called FOIL. Okay, that's when you multiply two binomials. Binomials just means two terms. So F stands for first. That's the first term, so I'm just going to do a check. The first terms would be x squared. Then the O stands for the outer terms, like the leftmost and the rightmost terms. So x times negative 9 is negative 9x. The I in FOIL stands for inner terms, so the ones that are almost touching. So we have 9 times x again, but this one is positive. And then L stands for the last terms, the last term in each binomial. So 9 times negative 9 is going to give you negative 81. And then when we combine like terms, we notice that these will go to 0, and you're left with the original. Okay, I'm not going to check every time, but you know, if you were on a test or quiz or something, you could always make sure that you factored this correctly. All right, but these aren't super hard. Okay, all right, so that's number 7. Number 8, we got to make sure that we're in the situation. If we're not in the situation of difference of squares, then we're just going to say it's not factorable. Okay, all right, so a squared, certainly a squared term. We notice that 25 is a perfect square, and b squared is also a square term, and we are subtracting. All right, so that's what we're checking. First term is a square, second term is a square, and it's the difference of those. Okay, so let's open this up. And then we basically just take the square root. So the square root of a squared would be just a, so that's our a term. And then our b term would be the square root of the second term, which is just 5b. Okay, so the square root of 25 is 5. The square root of b squared is just b. So we would go a plus 5b and a minus 5b. Okay, nothing difficult. Just got to identify your terms. All right, so on this one, we're going to take out the GCF first. Okay, so the reason we start with GCF is anytime that we see it, we're going to take it out before we do anything. So right now, 45 is not a perfect square. 5 is not a perfect square, right? And then if I just have one factor of m and one factor of n, those are not perfect squares either. All right, so as it is right now in this form, we are not in the situation of difference of squares. We certainly have a difference, but we don't subtract square terms, okay? But if we can identify the GCF first, then we may be in that situation. So the GCF of this, if I was to factor using just GCF first, we would take out a factor of 5. That's a common factor between 45 and 5. We have 3 factors of m here and 1 here, so we can take out a max of 1. Then we have 1 factor of n here and 1 factor of n here, so we can take those both out. Okay, and then we'll see what we're going to be left with. In this case, we'd be left with 9 m squared and then minus 1. Okay, so it's important that we recognize that once we take the GCF out, we are in difference of squares now. Okay, so here we're just going to rewrite the GCF. All right, that's going to come along for the ride. And now this piece, we're going to factor by difference of squares. 9m squared is a squared term, so is 1. It's the first of the perfect squares, and we are in the difference of squares now. So let's take the square root of each one. You'd get 3m plus the square root of 1 is 1, and then we'll write the same thing with a minus. And that's it. All right, so anytime that you see a GCF, you need to take it out and then kind of reanalyze what situation you're left in. Very similar idea in number 10. Let's start by taking the GCF out, which in this case would be, I think, 2x, because they're both even, and they both have at least 1 factor of x. And then we'd be left with 49 as the first term, minus, if we factor out 2x out of 8x cubed, we're going to be left with 4x squared. All right, and then we're going to reanalyze this. This is now difference of squares. So we have 2x, that's our GCF, and then we'll factor out the remaining polynomial. So the square root of 49 is 7, plus the square root of 4x squared is 2x, and we'll write the same thing with a minus.